Okay, hi science bowlers. Today we're going to do a little bit of electromagnetism. Before we do that, this is a note from the last video that I forgot to mention. We were talking about capacitors, and you have a parallel plate capacitor with a potential difference delta V across it, and the distance between the plates is D. You get an electric field set up in there that goes from the positive plate to the negative plate. The value of that electric field, actually, I'll write it the easier way to remember. The potential difference is equal to ED. So the electric field times that distance. And so you can actually see the units. The units for E are volts per meter. So I had mentioned that units for E could be Newton per Coulomb or volts per meter. So you can see that there. Okie dokie, hokey pokey. Let's talk about magnetism. How are magnetic fields even created? They are created by, so we call them B fields, by the way, magnetic fields. They are created by moving charges. Okay, when you think of moving charges, you probably think of a current. That's very reasonable. So if we have a current, we have a wire with a current I in it, what happens is that you get, and part of the difficulty with teaching about magnetic fields is that you have no choice but to go into 3 dimensions. If you have a wire, can you see that I'm holding this pen straight up? Okay. The magnetic fields are concentric circles around that wire. And so when you draw this, you say, okay, my thumb along the current, B field into the page here and out of the page here. So in and out. And then you get, oopsies. Oh, I'll just make that dot really big. So this is like a cross-sectional of a circle, right? Or you can also draw it like this. Okay, so concentric circles around. And so you use the right-hand rule for that. The value of that, and obviously for science bowl reasons, you absolutely do not need to know mu naught over 2 pi. That would be crazy for them to think you would have to know that. But the magnetic field strength, a distance r away from the wire with a value I, could be given by that, right? So maybe they would say what happens to the magnetic field if you have twice the current or twice the radius. So that might be useful. What are these measured in? Magnetic field is measured in Teslas. You could also measure them in Gausses. 1 Gauss is 10 to the minus 4 Tesla. So 10,000 Gauss is 1 Tesla. Fun fact, Earth's magnetic field is about half a Gauss. Cool. Here, I'll just shove this on this page to a solenoid. Is like, it's like a coil of wire, right, where you get a current coming in here. So what you get, the magnetic field created by this, is for an infinitely long solenoid, you get a constant B inside the solenoid, and B equals 0 outside the solenoid. To make this B stronger, you can put a magnet inside. And so this is part of something called an electromagnet. Because when you turn on the current, that's when you get a magnetic field. If there's no current, you don't have a magnetic field. Okay. Oh, this is fun. 2 currents. If they are in the same direction, they will attract each other. If they're in opposite directions, they will repel. So watch it. Ready? This current creates a magnetic field. Okay? And remember, it creates a magnetic field like this, right? So the magnetic field created by I1 at the position of I2 is into the page. And currents in magnetic fields feel forces. So the force on this current is I2 times the length times B1 times the sine theta, which in this case is nice and perpendicular, so that's 1. But if you do the right-hand rule on this, I, B, the force is this way. The force on 2 by 1 is this way. And when you do the same exact thing, you get the force on 1 by 2 this way. So, and then I would encourage you to do the opposite direction, convince yourselves that they repel too. So that's kind of fun. And I think there was a problem like this, right? Because you end up, right, you get ILB sine theta, but B was that thing that I had on the other page, mu naught over 2 pi, right? This was I2, this was I1. So what you ended up getting was the force between 2 wires. There's an L, so a lot of times we just say force per unit length. And there's an R, right? So I'm pretty sure there was a problem with like 3 amps and 3 amps and, you know, or whatever, or 3 times the current, 3 times the current. And so that was a useful thing. Groovy. Okay. Now let's get fun. Now let's get into electromagnetism. Okay, here, actually I'm trying to think, should I stop this video? Let me stop this video and then start a new one.